Welcome back to this edition of the tutorial. This is a past question, and it says that this is a past question. The first part is that find algebraically the coordinates of the points of intersection of the curve y equal 3x squared plus 6x plus 10 and the line y equal 2 minus 4x. It carries 5 marks. And the second part is write 3x squared plus 6x plus 10 in the form of this, and it carries 4 marks. And the third part says that hence or otherwise show that the graph of y equals 3x squared plus 6x plus 10 is always above the x-axis. Yeah, let's tackle it. Now, take your time to copy. We will need the whole board to start with the analysis. Take your time, copy it. Now, the first part says that find algebraically the coordinates of the points of intersection of the curve y equals 3x squared plus 6x plus 10 and the line y equal 2 minus 4x. Solution. Both the curve and the line will intersect if and only if their y values are the same at the point of intersection. Let me write it down. Both the line and the curve will intersect if and only if their y values are the same at the point where at the point or points where they intersect. In that case, we will equate the two equations because they intersect at a particular point or points. So, where they intersect, their y values will be the same. In that case, we have 3x squared plus 6x plus 10 equal 2 minus 4x. We are bringing the 4x at the right hand side to the left hand side and the constant 2 to the left hand side, the constant 2 at the right hand side to the left hand side. So we have 3x squared plus 6x minus 4 comes to the other side, it becomes plus 4x, and plus 2 from the other side comes to this side, it becomes 10 minus 2. Then the right hand side is left with 0. In that case, we have 3x squared, 6x plus 4x is 10x, and then we have 10 minus 2 is equal to plus 8. This the result is a quadratic equation in x, which we will solve it. Solving this quadratic equation, we see that if you are solving, I think that in the previous tutorial we laid emphasis on how to solve quadratic equation, and maybe we will recap Always the coefficient of x squared should be multiplied to the constant. In that case, we have 3 times 8, which is 24. Now, 24 has factors like the same as 3 times 8. We can also say that 24 is equal to 12 times 2. Okay. We can also say that 24 is equal 6 times 4. All these are factors of 24. Now, to do this one, I think we will try to add the factors. Here, the factors 12 and 2. If we add them, we can have 12 plus 2 equal to 14. If we add the factors, 12 plus 2 is equal to 14. Now, is the coefficient of x equal to 14? No. Then we rule this one out. Then let's come to the second factor, which is 6 multiplied to 4. If we try to add the factors, 6 plus 4, it will give us 10. Is the coefficient of x equal to 10? Oh yes, that's equals to 10. Therefore, this is the right factor that we are looking for. So in that case, this equation, instead of writing 10x there, it becomes 3x squared plus 6x plus 4x, then plus 8 equals 0. Very good. Then we will try to borrow this side to continue the analysis. We see that we are going to factorize from these two, this one and these two. We are going to factorize 3x outside. So we can see that this one is 3x. If we factorize this one out, we have x plus 2, meaning 3 multiplied to x is 3x squared. 3x multiplied to x is 3x squared, which is this one. 3x multiplied to 6 is 6s, which is this one. Now, this one that we have here, we will write the same thing over here, x plus 2. Then we find a factor that if we put it in front of here, it can be identical to plus 4 and plus 8. That is only possible when we put 4 here. In that case, 4 multiplied to x, it will be 4x. 4 multiplied to 2, it will be 8. Now we can see also that we can also see that this side there's the factor s plus 2. There's a factor s plus 2 and there's a factor s plus 2. We can factorize it out. So we have 3x plus 4. Then we factorize x plus 2. Anyway, all equal to 0. Therefore, we see that this quadratic equation that we see there, which is 3x squared plus 6x plus 10, is very much identical to 3x plus 4. X plus 2 equals 0. Now, it indicates that 3x plus 4 equals 0 and x plus 2 equals 0. If we take the first one, maybe let me borrow this section. This is section B, and this is section A, and I'll call this part. No, there's no space over there. Okay, so let me see. You can see that from here we can see that s equal to minus 4 over 3, and here x equal to minus 2. Yeah, you can see it on the screen. This is my remote. If I can see it here, you can see it there. Now, these two values of x are the coordinates of x, where the line and the curve will meet. Well, take your time to copy this one, and then we'll continue. Take your time. Yeah. Now we are continuing again. We have seen that the coordinates of the s coordinates of points of intersection, they are x equal minus 4 over 3 and s equal minus 2. So let's start with when s equal minus 2, then what will be the y coordinate at the point of intersection when x equal to minus 2? You can either use this equation to find the y value, or you can use this equation to find the y value. They will both give you the same result of y value. But instead of using this, it takes a bit time. Why can't you use the simplest y version to find the y value? That's what we are going to do. At your leisure time, you can try with this one as well. Because of the time propensity, we may not have time also to verify x equals minus 2 by using this equation. You can do that. Let's pick up this simple one. Y equal 2 minus 4x becomes, when x equal minus 2, then using this equation, y equal 2 minus 4, instead of x we'll say minus 2. So we can see that y, which implies y equal 2 minus 4 times minus 2. It will be 2 plus 8, which equal 10. Therefore, when s equal to minus 2, y equal 10. So let's call this coordinate as a. Therefore, a equal minus 2 and 10 is the first intersection between the curve and the line. Now let's use s equal minus 4 over 3 using the simplest version. When x equal minus 2, s equal minus 4 over 3, then using this equation, we have y equal to minus 4 minus 4 over 3. So we will have y equal 2 minus this minus 2 minus 4 times minus 4 over 3 is equal 2 plus 4 times 4, 16 over 3, which equal 6 plus 16 all over 3, which equal 22 over 3. Therefore, the coordinates of the second coordinates of intersection, we call it B. When S equal minus 4 over 3, then Y equal 22 over 3. Therefore, the two curves I'll continue from here. Therefore, the two curves, therefore, the coordinates of the points of intersection between the line and the curve are A minus 2 and 10 and B minus 4 over 3, 22 over 3. These are the coordinates of the point of intersection. Yeah, take your time to copy it, and then we'll pick up the second one and tackle it as well. Now, the second part of the question says that write a given quadratic equation in the form ax plus b in the bracket square, it says that a in the bracket x plus b all raised to the power 2 plus c. So this was the quadratic equation that was given. Y equals 3x squared plus 6x plus 10. This is no different from y equal 3x squared plus 2x plus 10. This, very good. And we will try to complete the square of this portion. This portion, if we complete the square, this portion is the same as x plus 2 over 2 square minus 2 over 2 square. Then we have our plus 10 over there. So we can see that this equation is still the same as y equal, okay, this portion, and then the 3 comes there. You can see that this portion where is being underlined with the graph with the pink mark is the same as this one. So this 3 is this 3. The bracket, this bracket is this bracket, these ones. So, and the plus. Now, let's try to do it again. So it becomes y equal 3, which is this one. Then we have x plus 2 over 2 equal 1. Then we have square minus 2 over 2 equal 1. 1 square plus 10. Very good. This is the bracket. There's a bracket here. Very good. This portion. Good. Then we have y equal 3x plus 1 square minus 3 plus 10. So we have y equal 3x 3 outside the bracket of x plus 1 square minus 3 plus 10 equal plus 7. Very good. Which is very much identical to x plus b square plus c, which was how the question was asked. Very good, very good. Now, what's the next part of the question? Where there are so many things that we can, we can analyze from this equation. Let me call it equation sigma. Now, from equation sigma, the next part of the question says that hence or otherwise show that the graph of y equal 3x squared plus 6x plus 10 is always above the x-axis. You can see. Let's come back to the equation again. From equation sigma, we find that y in fact equal 3x plus 1 square plus 7. This one is called the symmetrical term. And this term is called the y minimum term. Very good. You see that the y minimum is plus. Because the y minimum is plus, it tells you that the graph doesn't cross the x-axis. What's the meaning of that? Now, take it this way. The symmetrical term is a square quantity and it can never be zero. Therefore, this symmetrical term, we say that 3x plus 1 square is greater or equal to 0, which implies is 3x plus 1 square is very much identical to 0 as well, which implies is x equal minus 1. This one indicates that symmetry of the quadratic curve will pass exactly at where x equal to minus 1. Okay, this is the y minimum term. Now, if we are going to sketch the graph, possibly, if we are going to sketch the graph, is there a space here? Let me see. You can see that the graph will be like something like this. And this will be the symmetry where x equal minus 1, symmetry. And this is 10. And this is y minimum, which is plus 7, y minimum. Which is this point, 7. Maybe I will wipe off the board and then do a proper work over there. Take your time, copy it, and then we'll continue. Now let's continue. This should be the graph. This is the symmetry, a rough sketch, x, y. And this one here is s equal minus 1. And this is the y minimum, which is plus 7. And the symmetry, yeah. So you can see that the curve never cross, sorry, plus 7, sorry. You can see that the curve never cross the x-axis, never, because the y minimum term is positive. In case the y minimum term is negative, then you can say that the curve will cross the x-axis. That's the first, that's the way you can answer that question. There is also another way that you can answer the same question. This is alternative form of asking the question, but there is also another way. For instance, the equation of the curve was given us y equal 3x squared plus 6x plus 10, very much identical to ax squared plus bx plus c. Comparing the coefficients of x squared, we can see that a equals 3. Comparing the coefficient of x, we can see that b equals 6. Comparing the constants, we can see that c equals 10. Now, we are going to use discriminant approach. B squared is equal 6 squared, which is equal 36. For a c equal 4 times a, 3 times 10 equal 120. We can see that b squared being 36 is far less than 4ac. Therefore, this discriminant shows that when b squared is far less than 4ac, it indicates you couldn't see it. Sorry, you couldn't see it. Yeah, you couldn't see it. I can see from here. You couldn't see it. Let me push it forward. Yeah, you couldn't see it. I could see from my screen that I was out. So let me do it again. We see that b squared equal 36. For ac equal 4 times 3 times 12 equal 120 equal 120, which implies is b squared being 36 is far less than 4ac, which is 120. This discriminant indicates whenever a discriminant b squared is less than 4ac, it indicates that there is no real value of x for which the curve will cross the x-axis. Very good. So this is also another way to say that, in fact, that equation y equal 3x squared plus 6x plus 10 is always above the x-axis. Then we are done with that part of the question, the last part. And graphically, you can see that if we are to draw the graph, you can also see that honestly, the line y equal, see whether you can see there that section, the line y equal 2 minus 4x is a line with negative gradient. You can see that that line, if you draw this line, it will be like something like this. Something like this. This is it. This is just a rough sketch. But possibly, let's see whether we can do something about the graph. Just a minute. Let's consider the equation of the line. The equation of the line says that y equal 2 minus 4x. Intercept on y-axis, x will be equal to 0. Therefore, y equal 2 minus 4 times 0 is 0. Therefore, y is equal to 2. Is intercept on y-axis. On y-axis. Okay, intercept on the x-axis. Y equal 0. In that case, this y will be 0, so we have 2 equal 2 minus 4x, which implies 4x equal 2, which implies x equal half. So you can see that the graph that we are talking about, it will be like this, and then it will be something like this. Here is y equal 2, and here s equal half. Very good. This is the line y equal 2 minus 4x, x-axis, y-axis. Very good. But previously, we found out that for maybe let's do a proper sketch. Take your time, copy this one and copy this one, and we will try to do a proper sketch. Now, welcome back. This was in the previous quadratic graph. It looks like this. And we found out that it was like this. And this was 10. And this is y-axis. And this is x-axis. And this was y minimum, which was 7. Now, and this was the symmetry. S equal minus 1. Now, if we blend this one and this one together on the same axis, we can see that it will be like something like this. Yeah. So, these are the 2 points of intersection. And this is 2, and this is x equals to half. This point, s equals to half. So the 2 points of intersection that we had, one of them, depending upon the values, one of them should be A and one of them should be B. So this is the approximate curve that we were looking for. And these were the 2 points of intersection of the first part of the question. Now, we will bring this part of the analysis to close. And we'll continue again next time. Now, the Lord Almighty God bless you. The Lord Almighty God lift up his countenance upon you, lift up his face upon you, and give you peace. Shalom, shalom. God bless you. Bye.